Yeah, good morning. So first of all, I would like to congratulate all the students and the viewers for taking their interest in sedimentology as well as in sequence stratigraphy. During this lockdown period, even with limited infrastructure, I am trying my best to provide the basic concepts of sedimentology and sequence stratigraphy. We have already covered the basic concepts of sequence stratigraphy in 4 parts. If there is any confusion or any query, then I will prepare the 5th part also. Today we are going to discuss another very important topic in sedimentology, and that is the sedimentary structures. Last time we discussed about the sedimentary textures. Texture are generally smaller features, whereas sedimentary structures are large features. They are 3-dimensional features. They can be visualized in the field, directly in the field. So sedimentary structures are the structures which are very large in size. They are 3-dimensional in nature, and they can be visualized, they can be seen into the geological field work. The sedimentary structures are of great importance to a geologist because the sedimentary structures, which are formed by various processes, surface processes, they indicate the water depth, they indicate the energy, they indicate the physical, chemical and biological condition under which the rock was deposited. Generally, they provide the information about because any stratification, any deposition is initially horizontal. But after some time, because of the tectonic activity, deformation takes place, folding is formed or faulting is formed, which disturbs the strata, which disturbs the layering. It becomes very difficult to identify that which one is top and which one is bottom, and also the direction of the palaeocurrent. So the sedimentary structures are very important tools and techniques which informs us about the top and bottom of a bed, that is known as geopetal structures. All those structures which informs us about the top and bottom of a bed, they are known as geopetal structures. For example, mud cracks, rain prints, ripple marks, and all those sedimentary structures which provide information about the palaeocurrent direction, they are known as directional sedimentary structures. For example, the cross-cutting, they are the float cost. So sedimentary structures are very important tools which provides us information about the energy condition, physical, chemical and biological condition of the depositional environment. The most important deposition is like this. The most fundamental unit of sedimentology or sedimentary sequences are beds, are strata. If I am saying that this is one bed, this is second bed and this is third bed, it means number 1 is different than second is different than third. And this first is different than the second, and second is different than the third in terms of its physical characteristics, the shape, the size, the color, in terms of its chemical characteristics or in terms of its biological characteristics. A number of characteristics may not be visible into the geological field work, but certainly the physical properties, the size of the sediments, the color, its pattern, that is visible. So the most common or most fundamental unit of sedimentary sequences are the bed or the strata. It means a single strata is physically, chemically and biologically uniform. If it is different, then that will become different bed. So in any bed there are three parts. Number one, this is the lower part or bottom of the bed. This is the upper part or top of the bed, and this is the part which is known as within the bed. So there are three parts of any bed: the bottom, within the bed, and the top of the bed. And if the thickness of a bed is less than 1 centimeter, then that is known as laminae. So if anyone is using the term laminations, it means the thickness of that particular bed is less than 1 centimeter. There are three positions in a bed: the top part, the bottom part, and within the bed. It means sedimentary structure. There are certain sedimentary structures which are preserved at the bottom of the bed. There are certain sedimentary structures which are preserved within the bed, and there are certain sedimentary structures which are preserved or which are found at the top surface of the bed. We will discuss all these three types of sedimentary structures which are formed at the top surface of the bed, which are formed at the bottom surface of the bed, or which are formed within the bed. Generally, in the classification of sedimentary structures, there are two types of sedimentary structures. Number one is inorganic sedimentary structure, and the second is organic sedimentary structure or biogenic sedimentary structure. The organic sedimentary structures or biogenic sedimentary structures are trace fossils. They are also known as ichnofossils. And the stromatolites. So the ichnofossils and the stromatolites, they are the organic sedimentary structures or biogenic sedimentary structures. And the inorganic sedimentary structures are of two types: the physical sedimentary structures and the chemical sedimentary structures. Or the physical are also known as primary sedimentary structure. Chemical is also known as secondary sedimentary structures. It means all those sedimentary structures which are formed during or just after the deposition of the sediments or sedimentary rock, they are known as physical or primary sedimentary structures, and all those sedimentary structures which are formed after the formation of the sediments and the sedimentary rock, they are known as chemical and secondary sedimentary structures. So if anyone is asking about the sedimentary structures, then the primary sedimentary structures in detail, and in brief about the secondary and the biogenic sedimentary structures. But if someone is asking about the primary sedimentary structure or physical sedimentary structure, then we will describe only primary sedimentary structure. So I will discuss one by one, and the first I am going to start the physical sedimentary structures are the primary sedimentary structures. Primary are physical sedimentary structures. There are three types of primary or physical sedimentary structures. Number one, the sedimentary structures which are preserved or which are formed at the top surface of the bed. The sedimentary structures which are preserved or which are formed within the bed, and the sedimentary structures which are formed at the bottom of the bed. These are also known as sole structures, bottom of the bed. They are present at the sole of the bed. So first we will discuss the sedimentary structures which are formed at the top surface of the bed. We have already discussed in detail about the flow regime, that there are two types of flow regime and the Froude number: the lower flow regime and the upper flow regime. In the lower flow regime, Froude number is less than 1, and in the upper flow regime, Froude number is greater than 1. We have also discussed about the bed forms, that which bed forms are formed in the lower flow regime and which bed forms are formed in upper flow regime. So we have discussed that in the lower flow regime, first of all, plane beds are formed. Then with further increase in the velocity, ripple marks are formed, small scale. With further increase in velocity, sand dunes are formed. With further increase in velocity in the upper flow regime, plane beds are formed, and after that, anti-dunes are formed. So what are bed forms? Bed forms are the geomorphic units which are formed by the interaction of the sediment with the fluid. So if this is the sediment and this is the surface, and if the sediment is coming in contact with the fluid, the first bed forms will be formed like this. And what is this? This is the plane bed in the lower flow regime. With further increase in velocity, in this direction velocity is increasing, and these are the sediments. With further increase in the velocity, the ripples will be formed. These ripples are small scale ripples. With further increase in velocity, ripples are formed. These are large scale ripples. These are known as mega ripples. They are also known as sand waves. They are also known as sand dunes. With further increase in velocity, again the sand dunes are formed, sand waves are formed, mega ripples are formed, but these are two-dimensional in nature and these are three-dimensional in nature. With further increase in velocity, again the plane beds will be formed. The velocity is increasing in this direction. This is first, this is second, this is third, this is fourth, this is fifth. With further increase in velocity, anti-dunes are formed. They are in phase with the wave, whereas in the case of these sand dunes, they are out of phase with the wave. And in this, they are moving in upstream direction. The waves are moving in the upstream direction. So this is the sixth figure in which anti-dunes are formed. So this is for lower flow regime, this is for upper flow regime, and this figure clearly explains that how with the increase in velocity, the plane bed changes to small scale ripple marks, to the large scale ripple marks, two-dimensional, with again large scale ripple marks, three-dimensional, again plane bed, and the anti-dunes, they are formed in the lower flow regime as well as in the upper flow regime. So ripple marks are basically the undulations which are produced on the top surface like this. They are the undulations on the surface of the earth which are produced when the sediments they interact with the fluid. So if we just look at the anatomy of a ripple marks, anatomy of ripple marks. This point is crust, this point is trough, this is height or amplitude, and from this point to this point is the lambda, that is the wavelength. This side is known as Stoss side, the side which is gentle, and the another side which is steep is known as lee side. And the ripple index is very important factor. Ripple index is equal to lambda upon h, wavelength upon amplitude. And if ripple index is high, it is believed that the ripple marks are formed by current ripple marks. And if the ripple index is low, then they are known as wave ripple marks or symmetrical ripple marks. Generally, there are two types of ripple marks. Number one is symmetrical ripple marks, and second is known as asymmetrical ripple marks. In the case of symmetrical ripple marks, this is symmetrical ripple marks, and this is asymmetrical ripple marks. In the case of symmetrical ripple marks, the Stoss side is roughly equal to the lee side. The slope gradient, the inclination, the angle of Stoss side is roughly equal to the angle of lee side, then that is known as symmetrical ripple marks. In the case of asymmetrical ripple marks, the angle is not equal. The Stoss side is very gentle, whereas lee side is very steep. Generally, the symmetrical ripple marks are formed by wave action. They are also known as wave ripples, because wave means bidirectional. The asymmetrical ripple marks are formed by current. Currents are unidirectional. And the crust has different property. The crust may be straight, the crust may be sinus, the crust may be linguoid, the crust may be lunate, the crust may be catenary. So if this is the straight crusted ripple marks. This is sinus ripple marks. This is, if this is like this, then this is catenary. If this is like, the crust is like this is known as linguoid. And if it is like this, then this is known as lunate. And this is the, in all these, this is the direction of the movement of the current, the catenary, lunguoid and lunate. If in some of the cases the crust bifurcates, means if this is the direction, the crust is going like this and then it will bifurcate. The crust bifurcates. If there is bifurcation in the crust, it means that is formed by wave action. Wave ripples. It means the wave ripples are characterized by bifurcation of the crust, and they are characterized by symmetrical ripple marks. Whereas the current ripples, there is no bifurcation, and in the current ripples, they are generally asymmetrical. A third type of ripple marks that is known as interference ripple marks. They are formed by when there is both the current action as well as the wave action. Then there will be interference ripple marks. They are also known as tadpole nest, the interference ripple marks. Some ripple marks are known as climbing ripple marks. If the segments which are going to be deposited, for example in the deltaic setting, the segments which are going to be deposited, they are very high in suspension. And if the angle is toss angle is smaller than the angle of climb, this is the toss angle and this is the angle of climb. So if toss angle is less than the angle of climb, then the climbing ripple laminations are formed, and the climbing ripple laminations, they are very well visible even at the natural levee deposits of the Ganga plain rivers. We have seen in almost all the rivers the climbing ripple lamination either at the top of braid bar deposits or in the natural levee deposits. So these are the, again there are two type of ripple marks. Some are formed by water and some are formed by wind. There are two most important difference between the ripple marks which are formed by water and which are formed by wind. All those ripple marks which are formed by water, which are formed underwater, they are formed in shallow water. Whereas they can be formed in the wind if the velocity is low or if the velocity is high. Generally ripple marks, they are formed in silt and sand size sediments. The ripple marks which are formed by the water, their size is small, whereas the ripple marks which are formed by wind, their size is very, very large. So if you are getting very large size ripple marks in hundreds of meters, it means they are formed by eolian action or by the wind action. So this is the first sedimentary structure which is formed at the top of the bed, which is primary in nature and which is formed by, which is also known as physical sedimentary structures. Then the second sedimentary structure which is formed at the top surface of the bed is mud crack. Third is rain prints. Fourth is salt pseudomorph. Mud cracks are also known as desiccation cracks. They are also known as synthesis crack. Rain prints and mud cracks, they indicate that the desiccation is taking place, means evaporation is taking place, means the day temperature is high. Rain prints, if they are rounded or they may be elongated, if they are elliptical in shape or if they are elongated, it means when that rock was deposited at that time, the velocity of the wind was very high, and that makes the rain to become inclined. The salt pseudomorphs, generally they are, and rain prints, they are generally preserved in arid or semi-arid region. Salt pseudomorphs, they are preserved in the region where salinity is very high. Generally salt crystals are formed at the top of the bed when the bed submerged, they dissolve and the overlying unit is deposited in the form of salt. They are not original salt, but they are the pseudomorph of the salts. That's why they are known as salt pseudomorph. So all these sedimentary structures, the ripple marks, the mud cracks, the rain print, and the salt pseudomorph, which are formed at the top surface of the bed, they are very important in the identification of top and bottom of a bed, and that's why all these sedimentary structures are known as geopetal sedimentary structures. Only some ripple marks, especially the asymmetrical ripple marks, they can be also used for the analysis of palaeocurrent direction, and that's why they are also known as, the asymmetrical ripple marks are also known as directional sedimentary structures. So this is all about the physical sedimentary structures or the primary sedimentary structures which are formed at the top surface of the bed. In next lecture, we will discuss the sedimentary structures which are formed within the bed, which are formed at the bottom of the bed, the secondary sedimentary structures and the biogenic sedimentary structures. But only to name the sedimentary structures which are formed within the bed, I would like to write that all those physical sedimentary structures which are formed within the bed are cross bedding, tabular cross bedding, tangential cross bedding, and the trough cross bedding. The tabular and tangential, they are various types of planar cross bedding. Then second is the lenticular bedding. Third is the wavy bedding. Fourth is the Fraser bedding. Then fifth is the Homaki cross bedding. Homaki cross bedding. Then sixth is the herringbone cross bedding. I hope that in next lecture we will be in position to complete the sedimentary structure. Thank you and good wishes to all.